Okay, so we're doing test review for the kinematics test. This is the first problem I gave. So this is a dragon flying, and we wanted to find the acceleration from t equals 2 to 3. Oh, I did 2 to 3. I meant to say 2 equals 1 to 2 equals 3. And so to find that acceleration, we need to find the change in velocity over the time, which is the slope of the graph. So we take this slope of this line, and we said this is from 10 to 40, so this is a rise of 30 meters per second. So the dragon's flying, increases 30 meters per second in 2 seconds. Yes, Riley?
That change in the time didn't matter, right? Because it was constant acceleration.
It doesn't really matter.
Anywhere on that, constant acceleration would have been the same.
Yeah, that's correct.
Okay, got it.
Yeah, from t2 to t equals 3, it would be the same because it's the same slope.
Okay, just be sure.
Yeah, that's good. So we, oh, I don't have it there anymore. Oh no, I do. So the A part there is how you would find that slope, and that's the acceleration, but only from here to here, because the line changes in the first second. And you can use formulas for this too. You can say, well, my VI is 10, my VF is 40, divided by the time, and that'll give you the acceleration. So you're just using the first formula. Then I said, how far did the dragon fly in the first 3 seconds? So you're solving for displacement. If you just use the formulas, you might be tempted to say, well, it's 3 seconds, and he starts at 10, and she finishes at 40. So my displacement, I could just use the second formula and just plug in my VF is 40 and my VI is 10 and my time is 3, and then I could solve for the acceleration that way. But that's gonna run into trouble because she's flying at a constant velocity for a second and then she accelerates. So the displacement's gonna be a little different than if she just accelerated the whole time. So there's an easy way to do this. We find the area under the graph, and that's really an integral. So we chopped this into 2 chunks, and we said this was 10 by 3, so this is 30. And this is 2 by 30, which is 60, but it's cut in half, so that's 30. And so my total here is 60 meters. That's the quick and easy way to do it. Just find the area under a velocity graph, and that will give you the displacement. If you want to use formulas, you can do that, but you have to use a formula for this part first, because this is constant acceleration. It's actually 0 acceleration. So you can just do velocity times time. And then you have to use another formula for this part, and then add them together. But you can do that as well. And we did it over here just to kind of tell ourselves that we were right. So you can pause it there if you're watching the video if you want to figure that out. Okay, now I'm going to give you another slightly different problem. I'm going to give you a basic velocity one. Kiana, what's your favorite animal?
Dog.
A dog?
Yeah.
What kind of dog? German Shepherd?
Yeah.
Okay. So a dog runs at a constant velocity. You can write this down. Let's say she runs at what? See you, Benji. Good luck. You can watch this video later. I'm doing this for you. At 17 meters per second for, let's say, 12 minutes. No, actually, I'm going to say 17 kilometers an hour. That's Mr. Cowan sitting in there by himself watching crazy movies. Okay, so the dog, she runs at 17 kilometers an hour for 12 minutes. And the question is, how far does she go? Take a second and see if you can figure that out. $7.20? Does that make sense?
Yeah.
Seems like a long way.
Yeah.
She went,
That's what I got.
yeah? She went 3.4 kilometers in 12 minutes. It's a fast dog.
It was easier to like convert the 12 minutes to like
Oh yeah, you could just do that too.
hours and
You could just put this in hours. In my last class, I made them give me the answer in centimeters.
oh.
So then it's a little bit.
Where's the 720?
Oh, good question. I turned this 12 minutes into seconds. So I times by 60 seconds per minute, and then I got 720 seconds. Yeah, you're right. I made it too easy this one. Okay, tell me this in centimeters then.
34. Oh,
Divide by what? Oh no, no, you have to times by 100, right? So 3. If you add 2 zeros on, 340,000.
So,
Centimeters. So know your conversions. How many kilometers?
3.4.
Good. Divide by 1,000 to get 3.4 kilometers. That's a long way. Going 17 kilometers an hour. Okay, so you might have some kind of pretty simple basic velocity questions on your test. Probably only one or two, but just keep in mind if something's going at a constant velocity, as soon as I say that, what does that mean?
No acceleration.
No acceleration. Acceleration is 0. So you can just use this formula. You don't have to use the big 3. Okay, I'm gonna move this here. Who wants to stand on a cliff? Matthew would like to stand on a cliff. Matthew, what would you like to throw in the air?
Myself.
Yourself. Okay, he's gonna jump. Matthew's gonna jump upwards. This is a 15-meter high cliff. Hopefully there's like a trampoline at the bottom or something.
Some from the ocean.
Oh, okay, that's through the ocean, yeah. Even better. And he's gonna jump upwards and then come down. And he's gonna jump up at, Matthew's a very good jumper. He's gonna jump up at a velocity of 23 meters per second. That would be a very, very impressive feat, but we're gonna go with that. So, Matthew, oops. 2 T's in Matthew?
Yeah.
Okay. Matthew jumps straight up at 23 meters per second. He is on a 15-meter high cliff. And I want to know 3 things. So the first thing I want to know is how long until Matthew hits the water. I'm gonna hope this is in Greece or something, where the water's nice and warm. B, I want to know how fast he's going. How fast does he hit the water now? How fast is he traveling? When he hits the water. And then lastly, I want to know how high was he above the water at his highest point? So I'll say, what was maximum height? Try to do those 3 things. Once he leaves the ground, what's his acceleration?
Negative 9.8.
Good. 9.8 downwards. So negative 9.8. So we know that during his flight. What we know. Yeah, I said it was 23, which is very impressive. And we know his displacement till the end, right? Is his displacement 15?
No.
Ah, what is it, Artem? No, he's right, it's not.
66.
The displacement?
Yeah.
No. Where will he be when he hits the water compared to where he started?
Negative.
Negative 15, yeah. 15 meters down, so this is negative 15 meters. Okay, so who's struggling with A right now? Yeah, it's a little bit weird, right? You should be struggling. You can use this formula, but it's going to be nasty because your VI is actually something, and so you're going to have to use a quadratic formula to find the time. That's messy, and for most of you, prone to mistakes. I would suggest you do B first. I've asked you for the time first on purpose. What you really should do is find the final velocity first. That's going to make it easier to find the time. So I'm going to say let's work on B first and find his final velocity. Knowing this and looking for the final velocity, which formula would you use?
First one.
Second. First one has time. We don't really know the time yet, right? Callum, what do you think?
Second.
The second one. Let's do the second one first. But we gotta find displacement, right? Or sorry, we need to solve for the x. So we're gonna square root everything. Don't forget, when you solve for a square root, the answer can be positive or negative, right? We know he's going down at the end, so he's gonna have to have a negative velocity. Okay, so we put this in, and my VI was 23, and we have to square that, so negative 9.8, but that's okay because my displacement is negative as well. Bless you. That's a big mess. Somewhere around 29. Who else doing this? Did anybody else solve for this? Who got somewhere around 29? Who hasn't done it yet? Okay, so I'll give you some time. Carry on. I think you're gonna get around negative 29. Close to. Zed, do you know what's going on here? Yeah, do it. What'd you get?
For B?
Yeah.
Negative 29.
Okay.
Mine
Say it again.
ended up
Yeah, so your calculator will give you the positive answer, and so did mine. It doesn't tell you that the square root is positive or negative, but you know you can make it negative if you want to. So we make it negative because we know he's going down at the end. That's the only reason. Okay, so then let's do A after that. So we found the final velocity first. Now we can use that final velocity to calculate the time. Addie, if I know VF and I know these things, what formula am I gonna use to find the time?
First one.
Good. We're gonna solve this for time. So I'm gonna just subtract the VI over and then divide by A. And I know my VF now is -29 or so. Minus my 23. And that's all over -9.8. You can see why you have to make this negative, right? If this was positive, you'd end up with negative time. That would be bad. If you end up with negative time, you've done something wrong. So this is somewhere around 5.3. Got it, Angelo? Good. Put your hand up if you got somewhere close to 5.3. Good. You can work away on that. And then C is different. How are we going to find his maximum height? Kiana, what do you think?
His final velocity, or like a maximum, was 0.
Good. So up here, the velocity is 0, right? So Kiana's right. We just set our VF equal to 0, and then we can find out the time and the height and all that kind of stuff. Okay, let's do that. This will be on video now, so you can go back and look at it later if you want to. I'm gonna erase this part. So for C, we're gonna say we're looking for the max height above the water. So we're looking for displacement. So we say VF equals 0 because that's what it is at the top. And I'm going to use the second formula because I don't want to go searching for the time. But I'm going to solve this for D again. So I'm going to subtract my VI squared over and then divide my 2A under. And that should be my displacement. So I know my VF is 0 in this case, and I know he jumped at 23. Let me over that. So it'll be a pretty big number actually. He went really high.
Around 26.
28, 27 squared. How about you? 8. What did you get?
Around 26.
46?
26.
26.
Around 26.
I got 42. Oh, wait a minute. Sorry, I did it wrong. I put in the velocity from before. Squared divided by 2. Yeah, 27. 26.9. Yeah. Good. And that's going to be meters. Now, if you leave it at here, this is wrong, right? Why is this wrong?
Add 15.
Callum, say it again.
You have to add 15.
Good, good. This is his height above the cliff, right? So we figured out it's about 27 meters above the cliff. And so the height above the water, we've got to add 15. So this is going to be 42. Something like that. I was right after all. Okay, I'm gonna pause this video here because it's gonna be really long.